Good morning, everyone. Those who are present, I think, how many of you are there? 7 of you are there, right? So today we'll continue with last lectures. Okay, whatever we have done in last class. So in last class, what we have done is we discussed about the chopper. Okay, how basic fundamental means operation of a chopper. How does it work? Okay, all those details. I think we have studied on this. So what is chopper and how does the chopper works? And fundamental things about the chopper is it depends on it's just a switch. Okay, in a chopper, a switch acts whether to switch on for how long to switch on that the output that means what how long to switch on. So it depends on the input is fixed, the output is variable. So how are we going to manage those output voltage? So it's a DC to DC converter. So it's converting DC to DC. So we are just chopping, means we're trying to, there are two different types of chopper. One is step up and step down, buck and boost chopper. So there are other one also, which is also known as a buck boost chopper. And to understand ourselves, there are other classification, means there are other classification of class A, class B, class C. We'll look at on this. There are other classification also on choppers. So we'll look on these things later on. But now what you need to focus more is how does chopper works and what are the conditions to, means what are the different way to maintain the output voltage. Like what we have seen is pulse width modulation is much more convenient than the frequency, the changes in the frequency. So we know that we are talking about the, when you talk about the frequency or the modulations, where we are talking on the time frame. So if we keep the total time period constant, and if you try to play with the T on and T off, that we call as a duty cycle, T on divided by total time T, that is known as a duty cycle. So if you try to talk on this, then the output will depend on the duty cycle. So we need to like maintain this, means duty cycle. So based on our requirement, we can change the output, so based on the changing of the duty cycle. Now we have already seen the analysis of step down choppers, like how do you find out the internal resistance Ri, how do you find out the minimum current, maximum current, continuous circulating current, in terms of circulating current, in terms of a non-circulating current. So we'll just see that what's the principle of step of choppers. Step of chopper means your output is more than that of the input. It's just similar but it's just a DC. Okay, but if you see that it looks like similar to that of a transformer, but its transformer is, we are talking on in terms of an AC. So step of chopper is used to obtain the load voltage higher than the input voltage, that we have obviously talked about this. And there are values of L and C are chosen. So these values of L and C are chosen, okay, based on our requirement. What is our requirement at the output? So these two values are chosen. You must be thinking that how do we choose the value of L and C? So these two values are chosen based on our requirement. What is our requirement at the output? So and our requirement and output voltage and current. And when the chopper is on, so this is connected across the load, across the supply. So it means that when this chopper is on, so this is when the chopper is on, the inductor L is connected across the supply, and the inductor current I rises and the inductor stores energy. So you know this function of what is the function of inductor. It will inductor current will rise and the inductor stores the energy during the on time. So you know that during the on time, when the chopper is on, this will store the energy. L will store the energy during the on time of the chopper. Now, when the chopper is off, the inductor current will force to flow through the diode. So this, when the chopper is off, this inductor, whatever is stored on the L, it will force to flow through the diode. So this will flow through the diode and the load for the period of t off period time only. During the on period, this will means like inductor will store the energy. During the off period, it will flow through the diode and the load during the off period only. So the current will tends to decrease, resulting in the reversing the polarity of the induced EMF in L. So the polarity will decrease. So in of the induced EMF in L. So therefore, the voltage across the load is given by. So the voltage is given by V naught. Output voltage is given by V plus L di by dt. This is quite common. So you might have seen the similar type of equations in other places also. So it's V output voltage is greater than the input voltage. We are talking about the step up choppers. It means the boost converter. So a large capacitor connected across the load will provide the continuous output voltage. So you must be thinking that why do we connect these large capacitors? To have a continuous flow, that continuous flow of means continuous output voltage. So this is mainly used for the continuous output voltage. So diode D will prevent any current flow from the capacitor to the source. So this will prevent the diode D will prevent any current flow from the capacitor to the source when it is off. So step up choppers are used for regenerative braking of DC motor. So you must be thinking that why do you use these choppers? So especially this is used for regenerative braking off of DC motors. So
Sir, one question, sir.
expression for this. Now
Sir, one
expression
question.
for the output voltage. So you have to assume the average induced current to be I. So if you similar to what we have done in the step down choppers. So you have to assume that average induced current to be I during on and off time of the chopper. So you have to assume this induced current is equals to I. So during the condition when the chopper is on, the voltage across the inductor L will be equals to B, because the voltage will means this will start charging. The inductor will charge. So we will take as in voltage across the L will be equals to when the chopper is on, L is equals to V. So the energy, how much energy is stored on the inductors? V into I into T on at that period when the chopper is on. So energy, how much energy is stored? So how do we find out how the energy stored on the inductor? So which is equals to V into I into T on. This is the period. Energy stored in that inductor is the period when the chopper is on. So T on is the on period of the chopper. So similarly, when the chopper is off, it means the input voltage is 0. So energy is supplied by the inductor to the load. So it means that when chopper is off, the energy will be whatever energy is stored during the on period, that energy will be supplied by the inductors when the chopper is off. So voltage across L will be equals to V naught minus V. So energy supplied by how much energy is supplied by the inductors when the chopper is off? So which is L equals to V naught minus V into I T off. This is when the chopper is in off periods. So off period of the chopper. So if you try to neglect the losses, energy stored in the inductor L is equals to energy supplied by the inductor. So whatever energy is stored on the inductor, that energy will be supplied by the inductor L. So to find out VIT on which is equals to, so in which is equals to V naught minus V IT off. This is during the off period of when the chopper is off. So V naught will be equals to V T on plus T off. So if you try to simplify this equation and try to find out the V naught output voltage, then we'll know that V naught will be equals to VT divided by T minus T on. So what is T? So T is the stopping period or the period of switching. So total means that the time period, total time period. So T is equals to total time period, that is T on and T off. So if you try to simplify these equations in terms of a duty cycle is equals to T on divided by T. So if you try to simplify this equation in terms of a duty cycle, then we'll get this, because if you divide all this divided by T, then you'll get this will be equals to 1. This, if you divide all this by T, this is equals to 1, this is equals to 1 minus T on divided by total time T, this will be equals to D, duty cycle. So V naught will be equals to B1 divided by 1 minus D. So this is what they have followed. So B naught equals to V1 divided by 1 minus D. So the variation of the duty cycle D in the range of 0 less than equals to D, which is less than equals to 1, the output voltage B naught will vary in the range of V less than equals to infinity. So based on this equation, whatever we got in a step of chopper. So what are the performance parameters? So the thyristor require a certain minimum time to turn on and turn off. So it means that it will require certain time to turn on. When you trigger the ACR, it will require certain time to turn on and turn off. So that time, so duty cycles D can be varied only between the minimum and maximum value. So it means that duty cycle will vary between the minimum and the maximum value, and limiting the minimum and maximum value of the output voltage. So what we are talking, I told you in the beginning of the class also that we are just playing with the duty cycle. So it will vary between maximum and minimum value. So it will limit the output voltage, will limit on the value of the duty cycle. So ripple on the load current will depend inversely on the chopping frequency. So the ripple, it will depend on the what is the chopping frequency. So we know that T is equals to 1 by F, or F equals to 1 by T. So it will depend on the total time period, and which is inversely depending on the chopping frequency F. To reduce the load ripple current, frequency should be as high as possible. So if you want to have a higher frequency, then what do you need to know? You know the formula F is equals to 1 by T. So you have to manage the total time period. So let's do this problem. Okay, the chopper circuit is operating as the time ratio control at a frequency of 2 kilohertz on a 460 volt supply. If the load voltage is 350 volt, and calculate the conduction period of a thyristor in each cycle. Can you quickly note down this problem where the chopper circuit is operating on TRC, time ratio control, TRC at a frequency of 2 kilohertz. So it's operating at 2 kilohertz on 460 volt supply, where V is equals to 460, right? And VDC is equals to 350, and F equals to 2 kilohertz. Then you can find out the chopping frequency. T is equals to 1 by F.
0.5 millisecond, no, sir.
Try to share the other.
0.5 millisecond.
Okay, now in this one, okay, if you see here, V is equals to see here, V is equals to V is equals to 460 volt, right? So, and VDC is equals to VDC is equals to, I think that is VDC is equals to, what is VDC?
350 volt.
VDC equals to 350 volt. F equals to 2 kilohertz. Right? Now, from this, how do you find out the chopping frequency?
T is equal to 1 by
Chopping
F.
frequency F is equals to 1 by T. Chopping frequency F is equals to 1 by T. So T can be find out, we can find out that we have a frequency. So you just cross multiply with this. So F, we can find out T is equals to 2 into 10 raised to power minus
3
2 into 10 raised to power 3.
minus 3.
Right? If we, this is into kilohertz. So 2 into 10 raised to power 3. So what will be this? You will get 0.5 millisecond. So chopping means chopping frequency T is equals to 1 by F. So if you have to find out the time period, T is equals to. So output voltage is equals to output voltage. What's the formula for output voltage? VDC is equals to T on divided by T into V.
Sir,
So what is the total on time?
sir,
So what is the conduction period of the thyristor? So you have to find out T on. What is VDC? So we can find out T on is equals to VDC into T divided by V.
sir,
So we know that VDC is equals to, what is VDC equals to 350. Total on time T is equals to 0.5, right? So divided by, what is V? V is 460. This is a step down chopper, right? So what we'll get? 350 into 0.5 into 460. This is microsecond. Get 10 raised to power minus 3. If you try to convert this into second. So if you convert this, how much you'll get? T on will be equals to 0.38 millisecond. So this is a T on time. So you know T, right? T is 0.5 millisecond. T on is equals to 0.38 millisecond. Now we can find out T off. So T is equals to T on plus T off. T on plus T off. So from this we can find out T off is equals to T on, means total time is 0.5 minus 0.38. So we can find out T off also. So this, if you know the formula, it's quite simple. Okay, you just have to know that we know that V is equals to 360 and VDC is equals to 350 volt and F is equals to 2 kilohertz. So chopping frequency F is equals to 1 by T. So T is equals to 1 by, so we can find out the total time period. The output voltage is equals to VDC equals to T on divided by T into V. So we can find out T on equals to, this is the total on period.
sir.
So we are asked to find out, calculate the conduction period of a thyristor in each cycle. So we are asked to find out the T on. So T on is equals to, so this is how we can find out. V is equals to 460. Okay, VDC equals to 350 volts, and F equals to 2 kilohertz. So from this, what we got is T is equals to 0.5 millisecond, and so if you see here, to T on is equals to 0.38 milliseconds. So it's, so similarly we can do input to the step of chopper is 200 volt and the output required is 600 volt. So if the conduction time of a thyristor is 200 microsecond, you have to compute the chopping frequency, what is F. Then if the pulse is half, The second question is little bit, okay, you just have to understand the question carefully. If the pulse is half for the constant frequency of operation, if frequency is constant, right? But the pulse is halved for the constant frequency of operation, you have to find out the new output voltage. So in this, you have to pulse width is half for constant, if the pulse width is half for the constant frequency of operation. So if the T on is, if T on is half, if T1 is half, what is total T on time? Conduction time is 200 microsecond. So if this is half, it means that half of this is 100 microsecond. If the T1 is half, you have to find out the new output voltage. So what will be the output voltage if the on period is half? So initially the output voltage is 600, right? The output required is 600 volt. Now in this second case, if the T1 period is half, what will be the new output voltage? So try to find out if the pulse, if the on period is half, what will be the effect on the output voltage? That this question will really give you the idea that if your on period is, conduction period is half, then what will be the effect on the output voltage? So what we are talking is that what is the effect of the on period of that, of a thyristors on overall performance of a thyristor, means output of the thyristors. So if you see here, we know that VDC is equals to V is equals to 200 volt and VDC output is 600 volt, means this is a step up chopper. So T on is equals to 200 microsecond. So to find out the VDC, VDC is equals to VT divided by T minus T on. So we know that this T on period is there. So we can find out the total time period T. First question is to find out the stopping frequency. Once we know the T, then we can find out the F. F equals to 1 by T. So what we got in first from this equation is T is equals to 300 microseconds. So stopping frequency is 1 by T, means 1 by T. So we got 3.33 kilohertz. Now in second case, if the pulse width is halved, this pulse, the 200 microsecond T on period is halved, means if pulse width is halved, width of the pulse is half, it's 100 microsecond, then what will be the effect on the output voltage? The frequency is remaining constant, so output voltage will, the T will remain constant. So T total time period will remain constant. But the difference here is that only the time T on time is half of whatever is given on the initial case. So if T1 is half, then the output voltage is only 300 volt. So this is the effect on the output overall voltage, output voltage. So when the T on time is half, your output voltage is also half. Initially the output voltage is 600 volt, output DC voltage is 600 volt, but if the T on period is half, then the output voltage is also half. So from this question, that the output will mainly depend on the on period of the of a SCR, how long the SCR is on. So it means that how long the chopper is on. The next problem is, these are some of the critical. First one is quite simple. Okay, if you know the formula, you can just. And second one is just to give you some analysis. Okay, that what is the effect on the on period of the means SCR. So means on period of the chopper will affect on the output voltage. Now this next question is, a DC chopper has a resistive load of 20 ohm and the input voltage Vs is equals to 220 volt. When the chopper is on, its voltage drop is 1.5 volt and the stopping frequency is F is given as 10 kilohertz. Now in this case, the duty cycle is 80%, means 0.8. So determine the average output voltage and the chopper's on time. What is the on time of the chopper? Means T on, you have to find out. So initially it's given as Vs equals to 220 volt, R is 20 ohm and F is equals to 10 kilohertz. So we can find out from here duty cycle equals to T on divided by T. Means the duty cycle is given as 0.8. So voltage drop across the chopper is 1.5 volt. So it means that how much voltage is dropped across the chopper is also given. So average output voltage you can find out from this is equals to T on divided by T Vs minus VCH, means the amount of voltage drop on the chopper. The source voltage is equals to 220 volts. So amount of voltage drop in the chopper is 1.5 volt. So we know that VDC is equals to So T on divided by T is a duty cycle. So duty cycle is 0.8 to 20 minus. So there is a drop in the chopper also, across the chopper also. So your output voltage is 174.8 volt. So chopper on time. So T1 is equals to D into T. We know that T is equals to D equals to T1 divided by T. So we already know that T1 is equals to D into T. So T is equals to 1 by F. So we know that frequency is given as 10 kilohertz. So from here we can find out T. So T is 100 microsecond. So we know D, right? We already know that D is equals to 0.8. So T1 equals to D into T. So 0.8 into, so 100 microsecond, 0.1 into 10 raised to power minus 3. So T1 equals to 80 microsecond. So on period is 80 microsecond. Total time period is 100 microsecond. So it means that T off is equals to 20 microsecond. If you minus 800 minus 80, you will get T off equals to 20 microsecond. Off period is 20 microsecond and on period is 80 microsecond. Now, there's another problem. In a DC chopper, the average load current is 80 amperes, chopping frequency is 250 hertz, supply voltage is 110 volt, and calculate the on and off period. Means all these problems, okay, if you carefully see, okay, these problems are quite simple. If you know the formula and if you read the question carefully, whatever is given in the question, so if you know the given data, then if you know the formula, you can directly do these problems. So in a DC chopper, average load current is 30 amperes, chopping frequency is 250 hertz, and supply voltage is 110 volt. So calculate the on and off period of the chopper if the load resistance is 2 ohm. R is given as 2 ohm. So from here you have to find out the on and off period, means T on and T off. So we know that IDC is given as 30, F is 250, V is 110, R is 2 ohm. So you can find out from here chopping period, T is 4 millisecond. So IDC is equals to VDC by R. So from here we can find out VDC. Or VDC equals to D into V. So means VDC, we can, in place of VDC, we don't know what's the output voltage. So we know the it's equals to VDC by R. So from here we can find out the duty cycle. IDC into R divided by V. So duty cycle is, from this equation, IDC is given, which is equals to VDC by R. So VDC we can find out D into, it depends on the duty cycle. So D is equals to VDC, output voltage equals to input voltage into duty cycle. So from here we can find out the duty cycle D. So once we know the duty cycle, we can find out the T on and T off. So T on equals to D into T. We know what is D period. We already know the total time period is equals to 4 millisecond. So from here, T on equals to D into T. So which is equals to 2.18 microsecond. So if you know the T on, if you know the T, then we can find out T off, which is obviously total time period is 4. Total time period is 4 millisecond, and on period is 2.18 milliseconds. So if we minus this 2, T minus T on, then you will get T off, which is equals to 1.82 millisecond. This also you can do it yourself. Okay, try yourself. It's quite simple. Okay, if you just have to say this, whatever we have done here, all this, there are so many problems are there. Okay, please solve yourself. Okay, these are the formulas which you have already done in the last classes to find out the maximum current, minimum current. Now we'll go to the classification of a chopper. Choppers are classified as, okay, we have seen in last class, okay, that choppers can be classified into, there are different forms, okay, classification forms. So means in the, you can even classify it as input and output voltage. Last time buck and boost, or a step up and a step down, it depends on the output. So these are classified, what are, it means what are the different classification based on the class A, class B, class C, class D, class E. So these are the different type of classification of the chopper. So it is working on the first quadrant or second, how many quadrant, in which quadrant it is working. So based on this. So in this chopper, in chopper, it's working on one quadrant, the first quadrant itself. So the output voltage equals to B naught. So you have a freewheeling diode. You know that what is the function of the freewheeling diode? It's a chopper. This is the chopper. It's just a switch, which is used, means the STR is used as a, in this case, in chopper STR is used. So you need to know what is the output voltage B naught. So when the chopper is on, supply voltage V is connected across the load. So once this is on, the supply voltage is connected across this load. When the chopper is off, output voltage equals to 0, and the load current will continues to flow in the same direction through the freewheeling diode. So you know the function of freewheeling diode. So this will continues to flow in the same direction. So the average value of the output voltage and the currents are always positive. And a class A chopper is a first quadrant chopper. So please remember, it's class A chopper is also a first quadrant chopper. So class A chopper is a step down. It's a step down chopper, and which powers always flow from source to load, and it is used to control the speed of DC motor. So this class A chopper is used for the control of the speed of a DC motor. So output current equation obtained in step down chopper with RL load can be used to study the performance of the class A chopper. So if you want to know the details on this, or do this works in RL loads, by using the performance of the class A chopper. So in class A chopper, it depends on this is the gate current, gate thyristor gate pulses. So this is a period that means like on means like this thyristor is on, and this is the period when the FW, the freewheeling diode, will conduct. So this is the total time period. So it depends on the what type of load you are using. So the when the this is the output voltage will depend on this T on period. So this is T on, and total time period is total T. So this is output current. This is the period when the SL is conducting. This is step down chopper. So this is the period when the freewheeling diode is conducting. So total time period, you have to know this. And how do you find out the duty cycle from this? Now what I feel is, before going to this, okay, there are some problems, okay. Can you solve this problem? I think we'll stop here today, okay. Means chopper B, class B chopper, we'll talk next classes. So instead of going, okay, quite fast, we are already in third unit, okay. I think we just have 2 units only. Let's see how many units are there. So we just have a 2 units, okay. Means after that, means inverters. The other one is AC to AC converters. So DC to AC means the inverters are there, and next one is DC converters, or the cycle converters will see. So we have 4 different type of converters, and in power electronics, and the power electronic devices, the first chapter. So we have learned about the power electronics component. Then in second unit we have done the rectifier, AC to DC converter. Now DC to DC converter. Then we'll DC to AC converter. Then we finally will see the AC to AC converter. So we are already in third unit. So we just have two. Fourth one is not that much. Okay. So what I feel is that we'll stop here, and please solve this problem. Whatever problems are there out here. So please solve all these problems. Okay. And if you have any problems, so you can just write to me, or we can discuss anytime, whenever you feel like discussing. So do you have anything to say? Yes. Wait, okay, I'll just check here. think your attendance is set. Let me see. Yeah, I think it's there. Okay. So do you have, while solving the problems, I think I've given you some problems, okay, to solve. Unsolved problems are there as assignment, okay. And are you able to solve those problems? Some of you can just, if you feel like, I think we just do some discussion, okay, for a few minutes, okay. If you feel that to have some problems or solving those problems which is there in the PPT, I think I have given you those unsolved problems are there. I think on control converter. I think, if I remember, because
On
I know
control.
there are so many problems. Okay, if you see, I don't know how many of you have gone through the textbook. Okay, now if we go through all those problems, okay, some problems are really tough. So means like you need to really think about these problems. Means like you need to critically analyze those problems. Okay, now what I'm thinking is that instead of solving all those type of problem, okay, because it will be quite difficult for you to understand those complicated problems. So please try to focus on those problems which are simple direct application of formulas for now, so that if you have a time you can just go through this, because we don't have actual interaction in the classrooms. Okay, I mean, it will be difficult for you to understand those type of problem, and it will be difficult for me to even explain to you in online classes. So please try to focus on those problems, okay, which you feel is little bit easy for you to understand. Okay, and if you have a problem, I know you must be, if you are really interested in doing all different type of problems, okay, you can do it, no problem. But if you have any problems while solving those type of problems, okay, you can just directly contact me, or you can just write to me, and we can arrange a timing, and we'll try to discuss online also. So it's up to you. Means if you feel like, I know, okay, you may not be having the time to go through all those things, okay, because so in case of some of you, you must be in the villages, okay, and it will be difficult for you to continuously work on your, means like on the classes, and you might have to help your parents also. Some of you might be having the children which they must be disturbing you. I know this problem, but we don't have any options, so we have to go through the syllabus, and whatever is possible, okay, I'll try to help you. Okay, maybe we never know when you will be back to the college, but we have to continue with these things. Otherwise, means you might have to, if we do not do this online classes, okay, the other thing what I see is that, other thing what I see is that you might have to, like, if it continues till December, or if we have to come back by June, then we can finish by July or August. That's the strategic plan. I mean, like contingency plan. Okay, but we never know when you will be back to the college. So for that, okay, at least let's try to do our part. Okay, whatever is possible. So if you do not understand, when you are back, we'll discuss in the class. Okay, so that it will be clear for you as well as. But if you have to come, we cannot repeat whatever we have done till now, but we can go through randomly, we can go to the different topics and try to discuss on the different topics. And please, now it's clearly written in the today's schedule also, and it was given in the social media also, you might have already seen. Please don't go out in the street. There will be a strict action taken by the law enforcing agencies. Now police desuk will be there in the market, so you are not allowed to go out. All the shops will be closed by 7, so you are not allowed to go. Stay home, stay safe. Okay, please don't make, so I don't want to hear anything like, I don't want to hear anything that our students are caught by the police and all those things. Okay, so please stay safe. I know you all are grown up and you will not do all those things. So please do it and stay safe and study whatever is possible now. Okay, with this I'll stop here. So if we have, we'll discuss, keep on discussing in the next class. Okay, okay, goodbye and take care.